15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again, and thank you for joining us. This is the Space Nuts podcast, episode 219. My name is Andrew Dunkley. I'm your host, and with me as always, the professional professor of all things professorable, Fred Watson. Hello, Fred.
I don't profess to be any of that.
Thanks, I couldn't think of a word, so I just made one up.
That's all right. Yeah, well, that's a good thing to do. I make them up all the time.
Yeah, well, goes with the territory where I work. How you been?
Yeah, well, thank you. How have you been? All good here.
Oh, terrific. Judy and I did a road trip last week. We went out west of New South Wales, northwest. We went to an opal mining town called Lightning Ridge. I think a lot of Australians will have heard of it, but maybe people from overseas wouldn't have. But it's the only place in the world where you can get black opal. I saw a pendant, an opal pendant, for sale in one of the local shops there for $121,500.
I take it you bought it for Judy.
I just stole it and ran away. But it was remarkable. Beautiful gem. Yeah. Beautiful gem. It's the black opal, it turns out, is the second most rare gem in the world.
Well, there you go.
Behind the pink diamond.
Yes.
But on a weight for weight basis, it is one of the most valuable gems on the planet as well. Quirky place, strange little place. There's mines all over the place. They're actually in the town. Just to give you an example, you can get allocated a 50 by 50 metre section of land, and that's your mining entitlement. And what they generally do is they drill a hole down about 50, 60 feet till they get through the sandstone, and then they fossick around under there in the clay for the opal seam. We went down 2 mines while we were there. It's just an amazing place. And then we went to the iconic western town of Burke on the Darling River, and then came home through the mining town of Cobar. They don't mine opal; they mine copper, zinc, and gold. And again, the centre of the town has just got a massive open-cut mine in it. It's a really interesting place to visit. 3 very different but iconic places in Western New South Wales. So, because we couldn't go to Canada, we called it the Not Canada Tour Part 2, and we went out west. Yeah, which the locals very much appreciated too, I might add, Fred.
Yes, they would, of course. But you sent me a picture of the Astronomer's Memorial. What's all that about?
That was really interesting. That was in Lightning Ridge, which gives you an idea of how quirky the place is. Somebody on their actual mining allotment, you've got to imagine that usually you just build a shack on it to sort of sleep in while you're not working. But a lot of people who've gone out there have decided to go the whole hog and built houses on them. Yeah. Well, someone built this amazing structure and called it the Astronomer's Memorial. I didn't know it existed until I looked it up. And I went and had a look at it. But there's a bit of a dark side to it too, Fred. Unfortunately, the people who owned it has sold it to a neighbour, and I don't think the transaction went all that well. So she gets very upset when people go to look at it. Oh, okay. So while we were there taking a peek, she came out, and I thought she had a broomstick and she was going to smash me with it. So I didn't hang around too long. But yeah, I don't know much about it. Apparently all the famous astronomers are listed on a wall in there somewhere. But I think you have to be dead to be on the wall, oh, right. Fred.
That lets us off then.
Yeah, so you're off the hook.
So far.
Yeah, strange place. And there's another mining allotment where the guy has spent 20-something years building a castle.
Yes.
By hand, one stone at a time. And it is a fully fledged castle. It's got a courtyard, it's got a tower, it's got you wouldn't believe that it would be in the middle of a place like this until you came across it. And it's called Amigo's Castle, and it is remarkable. And he doesn't live in it. He lives in a shack out the back.
What else would you do? I do remember.
It's Lightning Ridge.
Yeah,
It's Lightning Ridge. That's
many
what they do.
years ago, that's right. I visited Lightning Ridge, and indeed have a friend who had a mine there. So we went down the mine and had a look at that. But it was his friends who were the interesting people, because they were all exactly as you've described, real characters, absolute characters, every single one of them. We had a great time.
Yeah, very, very eclectic, very, some of them right on the edge. It's a strange and amazing place, but I do highly recommend it as somewhere to stop over for a day or two, just to have a look around. And they've got these self-drive tours, and everybody sort of identifies themselves with car doors.
Oh, yes.
So they'll have the name of their property or their mine on a car door on a tree.
Yeah.
And they have a car door. They have 5 car door tours. So you follow the coloured car doors to go to different points of interest. It's brilliant. It's absolutely brilliant. I love it.
The other thing to watch out, and I remember this very clearly, to watch out for, because all these miners, because they're jealously guarding their properties, they've got dogs that are ones that you don't mess with. And I remember one of the friends of the people I went there with, the dog was tearing at the tyres of this 4-wheel drive, shaking the car. So we didn't get out. We waited for the friend to come out so we could actually get the dog under control. It was quite extraordinary. Frontier town.
Yes, indeed.
Yeah.
Oh, yeah. It's an amazing town. Very much worth visiting. Anyway, I think that's enough of that. We've been talking.
Right, that's the end of the show, Andrew.
It's all over.
Yeah, all over.
Can't do any more. But the topics of the day, Fred, we're going to look at the rusty crust on the moon. That sounds fascinating. A story that will be disappointing to some, but it doesn't mean it's an absolute no. But it appears there are no signs of alien technology from recent surveys. We'll talk about, very briefly, China's X-37B spacecraft and questions from the audience about Mu Scorpii and the expansion of the universe. So that's all coming up on episode 219 of the Space Nuts podcast. Now, Fred, let's talk about the rusty crust of the moon. What's happening to the moon? Why is it rusting? I didn't think there was any water or oxygen up there to do it.
Well, the moon's going rusty. It's not all of the moon. It's certain parts of the moon. But what's happened is there has been a reanalysis of data from the Chandrayaan moon mineralogy mapper, mineralogy mapper instrument, which flew. Chandrayaan was several years ago. It's an Indian space research organisation spacecraft orbiting the moon. Discovered water ice on the moon, and it essentially mapped out the minerals. It had this mineralogy mapper on board. And so there has been basically a reanalysis of some of the data that have come back from that. And what has emerged from that is signs of hematite, which is an oxide of iron. If I remember right, is hematite fool's gold? No, it's not. That's something else. Can't remember. Anyway, the oxide of iron, which is effectively rust. But hematite is present on the moon, probably in small quantities. But it was detected by the mineralogy mapper instrument. And it's a puzzle to understand how it gets there, because for hematite to form, you need oxygen. And the moon is not well placed for oxygen. It's got this hydrogen there, which is released by the water ice that's on the moon, but not oxygen. And so the puzzle has been to try and understand why that hematite is there. I think it's predominantly at the poles, which, of course, is where the water ice is as well, in these really deep craters that never get the sunlight. But the research that's been done, and this is quite a large group of planetary scientists, the work that they've done actually suggests that the oxygen comes from the Earth. And basically is transported along the Earth's magnetic field. So you've got to get this picture in your mind of what that magnetic field looks like. We're used to, bar magnets having a magnetic field, and that you can probably imagine the field lines being those kind of circular things. I'm waving my hands around here, Andrew. Not even you can see me, so let alone our listeners.
I could hear it, though.
Oh, you could hear it.
I could hear it.
Oh, that figures. Anyway, you know what a magnetic field looks like, but the Earth's magnetic field is highly distorted by the sun's magnetic field. And so the magnetic field sort of trails behind it. And the analogy that's usually used is it's just like a windsock. You know how a windsock points away from the direction that the wind's coming from. Likewise, the solar wind, the Earth's magnetic field trails behind it. And of course, the moon passes through that every month, basically. It passes through that windsock as it goes around the Earth. And that is the suggestion as to how the oxygen has got there, which has reacted with the iron to form this hematite. Really quite an extraordinary, an extraordinary story. And it might sound a little bit speculative, and maybe it is, but it is a model that works. The calculations that have been done on the possibility of this happening all come out positively. So it's big news. We can go iron mining on the moon. Maybe not, because there's not.
Oh, wonderful. Yeah. You see, people probably, and I'd be guilty of this, think that once you get to the limit of the atmosphere, that's where the oxygen stops. And as you do increase your altitude, the oxygen levels decrease significantly, and that's why they have to have oxygen supplies for those high altitude aircraft and some of the daredevils who go up there to just jump off a platform for the fun of it. But it seems that there is some form of oxygen going well beyond that. That's right. That seems to be the indication.
Extraordinary, yeah. And let me just correct myself for something I said earlier. Fool's gold is actually iron pyrites. I'm getting my iron compounds mixed up, or pyrite, sometimes called pyrite, because it looks like gold. Hematite, if I remember rightly, is black. So there you go. Or rusty, anyway.
I used to have a rock collection when I was a kid, put it together for my scout troop. So I had all of those in my rock collection.
You should have been straight.
I don't know whatever happened to it.
Yeah, it's probably like a lot of things you collect when you're a kid. It just somehow vanished one day.
It just disappears, yeah. I'm still looking for my first pair of Ugg boots. I don't know what happened to them.
Oh, they probably walked on their own, didn't they?
They probably were capable of it by the time I finished with them. Yes, indeed. All right. So the moon is basically rusting, and that sort of brings into play the future potential for mining the moon. It must have some interesting minerals on it that people would have their eyes on at some stage, I would imagine.
That's right. That's the next step, of course, is to go and trash the moon. Yep.
Yeah, well, we've crashed a lot of stuff into it, and left all our junk up there, so might as well go and dig a hole or two.
Yeah,
it'll end up looking like Lightning Ridge, basically.
That's right.
All right. You're listening to the Space Nuts podcast with Andrew Dunkley and Fred Watson. Let's take a short break now for a word from our sponsor, Namecheap.com. As their slogan says, search and buy domains from Namecheap at the lowest prices. This is the service the team at Bytes.com use to buy and manage our domains, and we're very happy with the service, support and value we receive. Can't recommend them highly enough. Buying the right domain name shouldn't be hard, and with Namecheap, we've found it to be anything but that. Find your dream domain and join over 2 million happy customers when you register with Namecheap. Trusted with over 10 million domains, you'll find you're in safe hands when it comes to turning your website idea into reality. They also have excellent tools to find the right name for you, like their handy search engine. Just type in your desired name, cross your fingers, and press search. If what you were after is already taken, they'll offer up some great alternatives. And if you're looking for some inspiration, try the new website domain name finder Beast Mode and discover thousands of domain names fast. We've found their prices to be excellent, management tools intuitive and easy to use, with excellent customer support should you need it. All in all, a great experience all round if you're looking to pick up a domain name or 2 or 3 or whatever it is you need. To check them out and help support us at the same time, just visit spacenutspodcast.com/namecheap. That's spacenutspodcast.com/namecheap. And Namecheap is one word. You'll be glad you did, and you'll find the URL details in our show notes and our website. Just visit the support page. Now, back to the show.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, a lot of people who listen to Space Nuts have their favourite podcast distributor, whether that's Apple Podcasts or, there's just squillions of them. A lot of people have been logging onto YouTube to listen to us, which is great, and that's fantastic. We need to get to a target of 4,000 downloads per episode, I think it is, and we're getting closer to it. I think we're over 3,000 per episode now that listen via YouTube. So thank you for doing that. And if you would like to, it's pretty easy to find us on YouTube, just in the YouTube search engine. Space Nuts Podcast is all you need to put in there. And you can subscribe. But whatever way you like to listen, we appreciate it and thank you. And keep on listening. And don't forget to tell your friends, share it via your favourite social media platform as well. If you know anybody who's keen on astronomy and learning as much as they can about what's going on out there, make sure you tell them about the Space Nuts podcast. We'd certainly appreciate that. Now, Fred, this next story is going to come as something of a disappointment, I suppose, to a great many people, but there's been a cross-section survey of 10 million stars, and there is not a drop of water on Arrakis, which is a metaphor for no signs of alien technology.
Exactly. At least not in the 17 hours of measurement that were made by this experiment that was done by people I know, actually, over in Western Australia. So the story is, it comes from a telescope called the Murchison Wide Field Array, which is at the Murchison Radio Astronomy Observatory in Western Australia, one of the most radio-quiet regions in the world. And that's also going to be the site of the Square Kilometre Array low-frequency antennas, which will be one half of the Square Kilometre Array, the other half being in South Africa. So the Murchison Wide Field Array is run by a group called ICRA, which is the International Centre for Radio Astronomy Research. Actually, it's run by Curtin University, but ICRA and Curtin University work closely together. And 2 scientists, I certainly know one of them, Steve Tingay, and his colleague Chenard Tremblay, I think is how you say the name. So those scientists have been using the Murchison Wide Field Array to look at a supernova remnant, which is very prominent in the southern sky. The Vela supernova remnant was beautifully imaged in colour using the UK Schmidt telescope by David Malin back in the 1980s, a very well-known image which kind of, set the pattern for colour imaging with visible light telescopes. We now have much better images than those because technology's moved on, but that's a region of tangled mass of hydrogen that is essentially the remnant of a supernova that exploded. If I remember rightly, it's of the order of 10,000 years old, but that's pulling it from my memory. So these scientists have been looking at that region, but they're looking in frequencies, right there. So they're using the Murchison Wide Field telescope. They're looking in frequencies that actually correspond to the FM frequency band that we use here on Earth. And their instrument is extremely sensitive. The other thing I love about the Murchison Wide Field Array is that it looks in many directions at once. It doesn't just look at, it looks essentially at a huge chunk of the sky simultaneously. It's a wide field telescope in the traditional sense of the word. And the Schmidt that I used to work on, the Schmidt telescope, was also a wide field one, but that was in invisible light wavelengths. Anyway, what they've done, the scientists have essentially looked for a long period in the constellation of Vela, looking for observations that will allow them to study the supernova remnant But essentially, they are also, because they're looking at in the FM frequency band, almost inadvertently, but of course they know they're doing it. They're not doing it unintentionally. They're also looking for any possibility of intelligent signals or artificial signals. Chenot said, the MWA, Murchison Wide Field Array, is a unique telescope with an extraordinary wide field of view that allows us to observe millions of stars simultaneously. We observed the sky around the constellation of Vela for 17 hours, looking more than 100 times broader and deeper than ever before. With this data set, we found no technosignatures, no signs of intelligent life. Now that's I guess it's to some extent to be expected. But if you would think that in those millions of stars that they've observed, if one of them had a planet on it or going around it with lots of FM signals escaping from it, and indeed they do from the Earth, the FM band actually escapes from the Earth, then you would think that we might pick something up. So they estimate about 10 million stars at a variety of distances have been surveyed by this technique in their 17-hour snapshot. There was another comment which may have come from Steve Tingay. Yes, Steve Tingay says, a quote that I love a lot because I've used it myself. As Douglas Adams noted in The Hitchhiker's Guide to the Galaxy, space is big, really big. And even though this was a really big study, he says, the amount of space we looked at was the equivalent of trying to find something in the Earth's oceans, but only searching a volume of water equivalent to a large backyard swimming pool. So they,
wow,
yeah. So
people are disappointed with the news that they've found no signs of alien technology. Could breathe a sigh of relief. We might have just been looking in the wrong place.
Well, that's right. There's only a small, just a small.
And with a 17-hour study, it's they could have all had blackouts simultaneously at that time and not been able to transmit.
And who knows what kind of technologies they're using. This search specifically, I guess, looks for civilizations like our own at the particular point in our own evolution technologically, yep, to where we've got to, where we are leaking radio signals into space. And the MWA is a great tool for finding that, if it exists. Of course, the same applies to the SKA itself, the Square Kilometre Array, because that is in many ways, even though it will look a bit different, is a kind of giant version of the MWA. It works in a similar frequency range, what is effectively the VHF band, FM frequencies. And so that instrument will have a much bigger range. And as I often trot out, because I love this statistic, apparently it can detect an airport radar at 50 light years, or it will be able to when it's built. Of course, it's not. Construction hasn't started yet. We hope construction of the SKA will start next year, the Square Kilometre Array, a kind of giant version of the MWA.
Yeah, actually looking at a photo of the MWA, it's amazing. It's made up of 4,096 dipole antennas that sit on a grid which resembles a spider web, and these things actually look like spiders.
They do, don't they? Yeah. It's
a fascinating antenna array. It just looks, if you're driving past and looking at it, you go, what the is that?
That's right.
Hard to get your head around.
In fact, it's the photograph you're probably looking at is really quite dramatic because it's taken from a very low angle. But actually, these things are only about 18 inches or 2 feet high.
Is that right?
Yeah, right. They're quite compact, and they remind me a bit of coat hangers as well. But
yeah. They do, don't they?
Yeah.
Yeah.
So the SKA itself will be similar, except the antennas they're bigger. They're sort of more than the height of, certainly more than my height, which is 1.93 meters or 6'4". They are like Christmas trees. They're a kind of different design from the MWA antennas. They just look like a forest of Christmas trees. And for the SKA, in Western Australia, there will be 130,000 of them, not just 4.
Good grief. Gee whiz, that's going to be a lot of tinsel every year.
Yeah, that's right. Exactly.
It's a worry. And you said you're 6'4", and before the total knee replacement, he was 6'2". So
who knows?
Obviously made a mistake there. But he only had one knee done, so he's sort of standing lopsided.
Yeah, probably.
All right. Well, there's still hope for life beyond Earth. Of course, the other thing to consider is, as you said, we're looking for people or life forms that have reached the same stage in evolution as we have. But there could be cave persons.
Oh yeah.
Or there could be planets that have just got animal life.
Yep.
And they can't sort of tell us anything about anything. So
or water planets.
There's all those possibilities.
Yeah, water planets with water planets with only marine life. That's
and all you can hear is.
Yep.
Sorry, what did you say? Although my theory is that the civilizations are looking at us and going, they're using FM.
Well, that could be could be true as well. That could be the case as well.
Maybe. You're listening to Space Nuts, and in some cases on the FM band. It's certainly the radio station I work for broadcasts on the FM band with Andrew Dunkley and Fred Watson.
1.
Space Nuts.
And again, we say thank you to those supporters who choose to go the extra mile and pay us $1 million a month to listen to the podcast. It's wonderfully generous of you. It's actually closer to a $1.50 a month. No, it doesn't matter, because if you have decided upon yourself to donate to the podcast, it is greatly appreciated, and thank you. If you do want to become a patron, you can do that through the Patreon website, patreon.com/spacenuts, or if you prefer to use another platform, you can do that through Supercast or Acast. All the details are on our website, spacenutspodcast.com. But thanks again to our patrons. Of course, as a patron, you get an ad-free early edition of the Space Nuts podcast, and we do add bonus material for Patreon or patrons every opportunity we get. So stand by for some of that in the not too distant future, although there's plenty there at the moment to work your way through. Now, Fred, we're going to talk about something that China's up to, but I'm guessing that there's not much to tell, because I assume this is all fairly top secret.
Yes, that's right. This was... It harks back to a story that you and I have covered a couple of times, which is the US military's X-37B spacecraft, which is something that looks like a quarter-scale version of the space shuttle. It's a space plane, essentially. It's launched vertically on a normal rocket launch vehicle, but lands like a glider, just as the space shuttle did. So we have had an announcement that the Chinese have got something similar. It was launched, I think, about a week ago, but on the 6th of September, the Xinhua news agency announced that they had successfully tested what they're calling a reusable spacecraft, and it had returned to its scheduled landing site after a 2-day mission in orbit. It launched actually on Friday the 4th of September. There you go, there's the date, from the Zhukan, I'm pronouncing that incorrectly, but it's a satellite launch center in the Gobi Desert. So really interesting, a snippet of news from Xinhua that perhaps the Chinese have got a very similar vehicle to the X-37B that may well be doing the same sort of research that the X-37B is doing. Apparently, we do know from independent observations that this vehicle reached an altitude of 350 kilometers, but it also did something that I know the X-37B itself was built to try out. Now, this is back in the late 1990s. when the X-37B was first initiated. And that was to do orbit inclination changes. So we believe that the Chinese version, the report I've read, says it was initially launched at an orbital inclination of about 45 degrees, but then performed a dogleg maneuver to change its inclination to 50 degrees shortly after launching. That comes from the Forbes account of this flight. So that's significant. You know, if you can change the angle of the orbit of a spacecraft, it means you're actually it means you're more versatile. It makes you more nimble in orbit, and of course, I guess that would be something that is always of use to the military, because these things, certainly the US one is a military space plane. We're not quite sure about the Chinese one because we know so little about it. There was a hint in the South China Morning Post from an unnamed source suggesting that to get an idea of what the Chinese version is like, you should look at the US X-37B. So it is very similar. Yeah. Interesting stuff.
And of course, both spacecraft are very mysterious because a lot of the time we don't know what the X-37B is doing. A lot of speculation, but sometimes they just don't tell you what it's doing. But it spends an incredible amount of time in orbit. It stays up there for years.
Yes, indeed. That's exactly right.
Rather extraordinary. So, and I'm guessing the Chinese are looking at it achieving the same kind of thing.
That's the surmise. That's right. We are really, clutching at straws at the moment, but it's an interesting development, and we look forward to hearing more about it.
Yes, indeed. It's the new space race, and China's catching up fast.
It's just one part of it. That's right. Yeah, China's doing very well, indeed.
Indeed. All right. Let's move on to some questions, Fred. And our first question comes from Nathan in Melbourne, Australia.
Hello, Fred and Andrew. Nathan here, coming from stage 4 lockdown in Melbourne, sitting in front of the pizza oven on Father's Day, enjoying a quick gaze at the stars. Andrew, great job with all that you do and putting this together. And Fred, thanks for your time. My question is, are you able to see a binary star, M01, SC0, or the alternate name is SA0208-102? Can definitely see them close together. I'm looking up, but when I use the app, it only shows the one star. So I just want to see if that's possible. Also, just wanted to see if you guys ever just go out and look at the stars without using the telescope and enjoy that just as much. Great show, and hope you have a great week. Thank you.
Thank you, Nathan. Hopefully things will be relaxed in the not-too-distant future for the people of Melbourne who've been going through a second wave of coronavirus and have been suffering through those significant lockdowns. But the numbers are starting to work back in favour of Melbourne. The caseload starting to drop, which is good news. But, our thoughts are with you, Nathan, and thanks for your kind words. Okay, he mentioned a binary star system. I'm sure you've heard of it, Fred?
Yes. So what Nathan's talking about is it's a pair of stars, which is a little bit more than a pair, as you'll hear in a minute, but they're called Mu Scorpii. So Mu is the something letter of the Greek alphabet. It's what we call a bi-letter, and it's, as you know, we've got Alpha Centauri, and all the rest of it. That's how they're named. The order of bright stars in a constellation are named basically in order of brightness. And when you get to Mu in the constellation of Scorpius, you've got Mu Scorpii. So Mu Scorpii is actually a pair of stars, and exactly as Nathan says, you can separate them with the naked eye. The separation is actually 1/10 of a degree. And so just for comparison, the moon is 1/2 a degree in diameter. So the separation is 1/5 of the moon's diameter, which is pretty easy to see with the naked eye. Just as an aside here, because of that figure of a tenth of a degree, on the 21st of December this year, we will have a conjunction of the two giant planets, Saturn and Jupiter, in the western sky, where their separation will be a tenth of a degree. It's a very, very close conjunction. Apparently the closest, 1623. They haven't been, they get close every 20 years or so, but they haven't been this close, for almost 400 years. So worth a look on the 21st of December. That's just a plug for something that we will no doubt talk about later on in the year, assuming we're still going by December. But Mu Scorpii, okay, so the two stars that you can see with the naked eye, one of them, and this is the one with the SAO number that Nathan mentioned. An SAO number. SAO refers to the Smithsonian Astrophysical Observatory. They produced a catalogue of stars many, many years ago, which I used to use in my research back in the 1970s. So this particular one is SAO 208102, and that is Mu1 Scorpii. So that's just one of the components of this pair of stars. But Mu1 itself, the SAO star I've just mentioned, is actually a binary system. And that is one that you cannot see. The stars are so close together, they're almost touching. They are in orbit around one another. And essentially, the only way you can detect that they're part of a binary system is by using professional equipment. You can't see them as a pair. You can see the effect of the fact that they are moving around each other in the spectrum of the two stars. So it's and actually it's also what we call an eclipsing binary, where one component, one of the pair of stars, passes in front of the other, and so the brightness changes. So yes, it's an interesting and complicated system. But I'm really glad Nathan mentioned it, because the last part of his question, do I ever go outside and just stare at the stars? Well, I do all the time. Almost every clear night, I go and have a look to see what the sky's like and just remind myself of what's happening up there. And yeah, so tonight, it's probably not going to be clear here in Sydney tonight because it's raining at the moment. But I will go and have a look at Mu Scorpii and see if I can pick out the stars in the tail. And because it's essentially the start of the tail of the Scorpion. That's where the star is. I'll have a look at it, see what I can find.
I too, Nathan, do pop outside and have a look around when it's not too cold, and especially on beautiful nights like we've had lately, and stare up at the heavens. I often don't know what I'm looking at because I know what's up there and I know the names of things, but I've never been able to really track things down as easily as someone like Fred could. But I use those interactive star charts from time to time if there's something I want to identify. They're very handy. But yes, I do like to look up there and see what's going on. And I always hope that I see something unusual so that I can talk about it on Space Nuts. But not lately, although Mars has been making a prominent appearance in the eastern sky here lately, and it's quite a sight to see, even with the naked eye, late at night. So thank you, Nathan, for your question. Nathan also said that he was talking to us, recorded his message on Father's Day, which may come as a bit of a confusing thing to say to non-Australians. But in Australia, we celebrate Father's Day on the first Sunday in September, whereas in other countries, they celebrate it at different times. I think it's in August in the US. But yes, it was Father's Day last Sunday here, which is always a frustration for my wife because Father's Day often falls on her birthday and she really doesn't like that. So we've got to be careful. Got to keep it low key. All right. Thank you, Nathan. Let's go on to our next question.
Hi, Andrew and Fred. I love the show. I have a question about the universe expansion. I think you have mentioned this several times. And if I understood it correctly, the universe is isotropic and expands equally in all directions. I can't get my head around this. Expands equally in relation to what? I think you also said that there is no center of the universe. How can that be? If it expands equally in all directions, this kind of implies there is a center. Or Thanks, and keep up the good work. I can't wait for the next episode of the podcast.
Thank you for your question. And I think you and I have had this discussion before, Fred, about if it's going out in all directions at the same time, at the same speed, there has to be a middle.
Well, yeah.
And that's what he's asking. And we don't know his name, but we appreciate the question. Did you pick the accent?
Well, I could, yes. I wondered, I would hazard a guess at Austria, but who knows?
Yeah. Could be. It's a bit too soft to be German, from what I can tell. But anyway, nice to hear from you. And yes, it is a confusing issue, the expansion of the universe. So Fred will solve it all for you right now.
Thank you. Thank you and good night. Look, it comes down to what we can observe, because that's really the significant thing. And what we observe is galaxies moving away from us in all directions. They move away at the same rate, proportional to their distance. So what we used to call the Hubble law, but is now called the Hubble-Lemaitre law, because Georges Lemaitre, who was a Belgian priest who actually did a lot of this work in the 1920s, has always been neglected a bit. So we now include him in the Hubble law. What that says is that the speed a galaxy is moving away from us is directly proportional to its distance. The further away a galaxy is, the faster it is receding from us. And that is true over the whole sky. So the Hubble-Lemaitre law works over the entire sky. In other words, it is isotropic. That means that the recession velocity is changing at that rate everywhere the same. I'm not perhaps expressing that very well. So what you might immediately infer from that is that we are at the center of the universe, because everything's racing away from us and the universe is clearly expanding. But it's actually not the case. That's just an artifact. And the analogy that has always been given in astronomical textbooks is to imagine a fruitcake, which is basically expanding in the oven as you cook it, and all the currents in it are moving away. Their separation is just increasing as the expansion goes ahead. And no matter whereabouts you were in the fruitcake, you'd see the currents expanding away from you. And that's the same with ourselves. No matter where you are in the universe, you are going to see this Hubble-Lemaitre effect. You'll see the galaxies moving away at a rate that is proportional to their distance.
I've got a bank account that does exactly that.
Yeah.
Everything moves away.
Yeah, well, there you go. This is a veiled appeal for more Patreons, is it?
Could be. I've also got a share portfolio that's doing all that at the moment too.
Never mind. Anyway, that's a different story. Yes, you could imagine that maybe we are the center of the universe, but we're not. We are just a random point in the universe. Now, the big question is, we really don't know how big the universe is, and we don't know whether it's got any boundaries. These are, the things that people study, and there are various theories that relate to these ideas, but we don't know for certain. The universe could be infinite.
And if it is, there is no middle.
Yes, that's right. Well, that's right. So there's no middle. And that also links with the idea, which basically is turning the Hubble law on its head. If everything's expanding away from everything else, then there must have been a point when everything was in the same place. Must have been a time. And that's when what we identify with the Big Bang, 13.8 billion years ago. So if the current best bet theory, which is based on Einstein's theory of relativity, is true, then at this point in the distant past, 13.8 billion years ago, the universe was a singularity. It was a point with no dimensions. Now physics doesn't let us handle that at the moment, but that's the inference from what we can measure. And that means that everything in the universe was in the same place. And then it expanded, and now everything that was next to each other at the start is now widely separated, but any point in the universe could be regarded as the middle because it came from something with no dimensions. That's the tricky bit. It is totally counterintuitive, Andrew. I absolutely understand why this does people's heads in. It does mine in too. But basically, if you think about what observations we can make, it sort of makes more sense. That isotropy of the expansion comes directly from our observations. The universe is expanding at the same rate in all directions.
Okay. Hope that helped with your confusion. It is a very, very odd thing to try and get your head around, I must confess. But appreciate your question. Thank you for doing it as an audio question. We certainly do encourage that, which you can do on the AMA tab on our website, spacenutspodcast.com. Click on the AMA tab. If you've got a device with a microphone, it's as simple as saying, "Hi, I'm Fred from Sydney, and I have a question about Andrew's golf game. How good is he really?" It's got nothing to do with astronomy, but it's got a lot to do with physics. But that's as simple as it is. If you want to ask us a question, we love audio questions, but we do get them on text as well, and we're more than happy to take them that way. You do not have to speak if you do not desire to do so. But we did actually get a really big batch of them the other day, Fred. Which is great. So we're going to dedicate next week's show, episode 220, to answering as many questions as possible because we've got quite a backlog at the moment. Now, Fred, I have another piece of audio that's not a question, but I did have a bit of a whinge about my sore back last week. So somebody sent me some advice.
Hello, Andrew. So sad to hear of your back trouble, but a little bit of advice from someone who's been there. Get your GP to give you a referral to a neurospine specialist. Ditch the chiropractor. Get some real help. I'm sure it's the way to go.
Now, I don't know where the nearest neurospine specialist to Dubbo would be, but I'm guessing it's at least a 6-hour drive. So
do your back in.
Your advice, which would do well. My back was terrible after the driving last week, so yes, you're right. Yeah. But thank you for the advice. I will look into other possibilities. It's a lot better. It's still sore, but I can get up and down without any trouble, and I can even put my socks on now. It was that bad I couldn't bend over to put my socks on, which was tragic, but it is getting slowly better. But I'm now advised that I need to do some core exercises to build up strength in my lower back and my glutes so that the spine is better supported to avoid the problem in the future. So apparently, Fred, a side effect of our sedentary society is that our glutes become useless. Yes. And when that happens, all the work moves to another part of your body, and wham, bam, thank you, ma'am, back pain. Simple as that.
Yep.
So do your back exercises, everybody.
Yeah, I do.
What I'm told.
Part of the physio for the knees, keeping those core muscles working properly. So I do my back exercises.
Indeed. All right. Enough of our medical conditions, Fred, I think.
We're falling to bits here. What a pair of old...
Here we are. Oh, dear. That's all right. That's why they made super glue.
Yeah, exactly. Which is actually
Thank you, Fred.
Which is what stuck my knee together, by the way.
I kind of guessed that.
Unbelievable. Oh dear!
Wonderful stuff.
It's time we got going. This is turning into completely the wrong conversation.
Not a problem at all. But I look forward to your company again next week, Fred. Thank you.
Thanks, Andrew. See you later.
See you soon. Fred Watson, Astronomer-at-Large, part of the team here on the Space Nuts podcast. And from me, Andrew Dunkley, thank you again for listening. We'll catch you on the next edition.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.